Welcome, everyone. My name is Allie Dunn, and I work on the Strategic Alliances team here at First Book. Thanks for joining our final installment of STEM Careers All Year, focusing on diversity in STEM and how we can all find our identities through STEM education and careers. This is made possible through the generous support of General Motors and their partnership with our organization, First Book. We are so excited about this month's STEM Careers session, where we will get to hear directly from Dr. Theanne Griffith, the author of The Magnificent Makers. I'm now going to introduce my friend Kelsey Gaines. She is the Senior Manager of STEM Education at GM, and she will share more about today's GM-sponsored session. But first, let me just remind you that after Dr. Griffith's reading, please make sure to share your questions in the Q&A box so Kelsey can share them with Dr. Griffith after the reading and special activity. Now I'm going to hand things over to Kelsey.
Hi, everyone, and thanks for joining today. My name is Kelsey Gaines. My pronouns are she and her, and I serve as the STEM Education Program Officer on our corporate giving team at General Motors, which means that I have the wonderful opportunity of working with nonprofit partners across the country like First Book. At GM, we're working to become the most inclusive company in the world, and we know that we have a responsibility to make STEM education more accessible and equitable. We know that we have to equip diverse communities with future industry-relevant skills that will accelerate the path to an equitable STEM employment pipeline. We also want to make sure that students just like you have the opportunity to develop a STEM identity and foundation that allow you to pursue your natural curiosities in STEM. And this will help create access to future career paths in STEM education. As we can continue to develop a more technologically advanced society, it's important that kids from all communities fall in love with STEM. And we want to make sure that kids just like you are making up the next generation of innovators and leaders in STEM. Today you'll learn more about this, but STEM is everywhere. All of us work with STEM every day, and it's all around us. And it's in your classroom, the books you read, the TV you might watch, and everywhere you look outside. And we are so excited to work with First Book and provide these monthly STEM Careers All Year events. And we are so excited to have our last one today with Dr. Theanne Griffith. And Dr. Griffith is a neuroscientist and award-winning author of the STEM-themed chapter book series, The Magnificent Makers, and co-writes the nonfiction series Ada Twist, the Scientist, The Why Files. Dr. Griffith received her undergraduate degree in neuroscience and Spanish from Smith College and earned her doctorate in neuroscience from Northwestern University. She is currently an assistant professor at the University of California, Davis, where her lab investigates how our nervous systems encodes bodily sensations such as temperature and pain, and she's going to talk more about that today. Since she was a little girl, Dr. Griffith has loved both storytelling and science. As a children's book author, she blends these two passions while also working to promote diversity in STEM and inclusive representation in children's media. And with that, I welcome to our screen Dr. Griffith.
Hello, everybody. I am so very excited to be here with you today and talk to you a little bit about the science that I do, share my love for science stories, and then also do a fun little experiment. So thank you again for that lovely introduction. Again, my name is Dr. Theanne Griffith, and I'm a neuroscientist and children's book author. So today, first, I'm going to tell you a little bit about the science that I do in my lab. Then I'm going to talk to you a little bit about my hobby or my side hobby of being a children's book author. Then we're going to read from the 5th book in my Magnificent Makers series, Race Through Space. Then we're going to talk a little bit about flight and how things fly, which is based off the 1st book in the Ada Twist Scientist Why File series. And I'm going to do a quick little demonstration that I hope helps you understand how things like birds and planes are able to fly. Okay, so let's go ahead and dive right in. So first, I'll talk a little bit about my research. So I'm a professor at the University of California, Davis, and I run the Griffith Lab, as you can see here. So this is a little picture of me and my student Cyrus, who were doing some experiments one day. This is the building that our lab is in, up here in sunny California. And this is a picture of some of my lab members putting together some equipment. This was when my lab first opened its doors a little bit over a year ago, about a year and a half ago now. So we didn't have too much set up, and so we were getting things going. My students were getting things going in that picture. But the main question that our lab is really interested in is, how do we feel things? It sounds like a really simple question, but it's actually kind of complicated. So when we talk about feeling things, what we're talking about are bodily sensations. And these bodily sensations include things like pain. So when you stub your toe and it hurts, that's a painful bodily sensation. Also touch, when you give somebody a high five or a hug, or even when you're holding something like a water bottle in your hand, you feel that, right? So that's our bodily sensation of touch. I don't know about you guys, but the bugs have been eating me alive so far this season, and I have bug bites that itch. Itch is also an important bodily sensation. And then obviously temperature. We feel whether it's hot or cold outside, or maybe perhaps very comfortable. So how do we feel these bodily sensations? Again, that is one of the main questions that my lab answers. And as a neuroscientist, I study our nervous system. So for those of you who might not be familiar, we have two main nervous systems. We have a central nervous system that has our brain and our spinal cord that runs down our back. But then we have this other nervous system. And this is the nervous system that people don't really know about as much. And it's called our peripheral nervous system. And this is the nervous system that I study. So our peripheral nervous system is made up of different kinds of sensory neurons. So here's a little picture of a sensory neuron. And I know it kind of looks like an alien, but this is actually more or less what they look like, although they're much bigger and longer than this. So like all neurons, sensory neurons have what we call a cell body. And then they have these projections that stick out like this. And one of those projections goes to your skin. And those projections are there like little satellites to pick up all of these signals in our external environment. Signals like pain, temperature, touch, and itch, just like we just talked about. So we're able to feel all of those different bodily sensations because we have, like, you can think of them as like little neuron feet all over our skin. So if you were to look at your arm right now, your arm is completely layered with all different kinds of little neuron feet that are sitting there like satellites waiting to pick up information in your external environment, in the environment. So like if someone comes up and taps you, you have little touch sensing neurons that says, hey, someone's tapping me on the back. Or if you go to open your fridge and you feel that gust of kind of cool air, you have some cold sensing neurons that say, whoa, that was a little more chilly than it was a couple seconds ago. So those sensory neurons pick up all of this information from your skin, and then they send it all the way to your spinal cord. Now, as I mentioned, on the screen, this cell looks maybe not so big, but I am about 5 feet 10 inches tall. So I'm pretty tall. And if I look down at my toe, there is a little neuron foot right at my toe that if I stub it or something like that and it hurts, that signal has to travel all the way up from my foot to my leg to my spinal cord. So that's a pretty long distance. That's almost 3 feet, right? So these neurons really send very far-ranging projections to be able to pick up all of this sensory information in our environment. And so my lab is really interested in how those signals are sent. Again, it sounds like an easy question, but it's something that we're really still trying to figure out. Because sometimes when people get sick or they injure themselves, something that normally felt okay, like a hug, can start to hurt. And so it's really important to understand how these signals are sent normally. And so I just wanted to also share with you guys this picture. So this is a picture of these sensory neurons. And although I'm just showing you one here, in the cartoon, it's just showing one. Actually, in our body, these sensory neurons group together in little bundles, and those bundles line our spinal cord. So this is a picture of a section of one of these bundles. And you can see here that there are tons of neurons in there. And so all of those neurons from all of these little bundles are just sending projections all over your body. And again, what I'm really interested in my lab is figuring out how those signals are sent. And that is the main question that I address as a neuroscientist. But as I mentioned, scientists, we love research. We love being in the lab. We love doing experiments. But we also often have hobbies. So some scientists like to go rock climbing, for example. I have a lot of scientist friends who like rock climbing as a hobby. I also have scientist friends who are in bands, like rock bands, and they sing and play musical instruments as a hobby. I, on the other hand, I like to write. I love to tell stories. Ever since I was a little girl, I've been really excited to read and write. And I've also been a flight. What does it mean to fly? So flight is when an object moves without touching anything on Earth. When something is flying through the air within our atmosphere, that's called aviation. So when birds, bugs, planes, helicopters, when they fly, we call that aviation, and we call the people, if they're flying an airplane or a helicopter, aviators. And when something is flying through outer space, so when it leaves our atmosphere, that's called space flight. So rockets or satellites that are orbiting in outer space, they're doing what we call space flight. But either way, flight is when an object is moving without touching anything on Earth. So how do animals or objects fly? So birds fly using 4 different forces. So there are 4 forces in flight. There are thrust, lift, weight, and drag. So thrust is a force that pushes something forward. Lift is a force that pulls something up into the air. And the opposite of thrust and lift are weight and drag. So drag pulls something back, and weight pulls something down. Okay? And so if you want to think of force, you can think of something like gravity. Gravity is always pulling us down to the earth. Even though we can't see it and we can't really feel it, it's always there. So that is how force works to help things fly. Birds and planes, though, take advantage of these forces with very specially shaped wings. So the wings of flying birds, they're curved on the top. On the other hand, they're flatter on the bottom. And this makes a very special shape called an airfoil. And this airfoil shape, it causes the air that's going over the top of the wing to move faster than the air that's below the wing. And this difference in the speed of air movement creates a lift that pushes the bird up into the sky. Birds will also make thrust by flapping their wings. That is what's going to push a bird forward. When a bird wants to stop, they're going to hold their wings up in the air. And this is going to catch a lot of wind in their wings. That's going to create drag. That's going to slow them down. You can kind of think about the 4 forces of flight like if you're on a swing. If a friend pushes you, they're going to thrust you into the air and you are going to lift off. But your weight and gravity are going to pull you back down. And if your friend wants you to stop, they might grab the chains that are holding the swing, and that's going to create drag to stop you. So those you can think about as the 4 forces of flight. Now, do all birds fly? No. And that's because not all birds have this special airfoil wing shape. Some birds, like penguins, actually have flippers. And so it's a lot easier for them to swim. They can swim very, very well and very, very fast. But with those flipper wings, they cannot fly. There's another bird called a kiwi that's in New Zealand, and they basically don't have wings anymore. They almost have like these little nubs. And those wings are just way too small for them to be able to get lift off of the ground. What about chickens? Do chickens fly? Not really. So they actually kind of can fly. A lot of people think that chickens don't fly, but in reality, they can a little bit. So I'll tell you one quick fun story. I live here in Northern California, and it's kind of rural where we are. And one day I was on my way to work, and I drive past one of the farms that I pass on my way to my lab. And I looked up and could not believe my eyes. I saw chickens in a tree. I kid you not, there were chickens up in a tree. So chickens have small wings, but not as small as a kiwi. So they can fly a little bit, maybe enough to hop up onto a fence, or maybe enough to get up into a tree. They can't fly very long distances though, like birds that maybe migrate from Canada down to Mexico. They can just fly short distances. And again, this all comes down to the shape of their wings. Now, people over 100 years ago were trying to figure out how to fly too, and they got inspiration from nature. So believe it or not, plane wings are modeled after bird wings. They also have more of a curved surface on top and a flatter surface on the bottom. And again, this specific shape makes the air that is traveling over the top of the wing move faster. And again, this faster moving air weighs less than slower moving air. And so that causes the plane, once it turns on its engines to generate all of that thrust, to then lift off into the air. And I know that kind of doesn't really make sense. It's kind of hard to envision how fast moving air over the top of something might create lift. But that's what experiments are for. And this idea is called Bernoulli's Principle. So what we're going to do now is a very quick and easy science experiment that you can also demonstrate that you can also do at home. All you need is a piece of paper, okay? So what I'm going to do is, for now, I'm going to fold this piece of paper in half, okay? And you can either cut it with scissors. I'm just going to cut it with my hands. It doesn't matter if it's perfectly straight or anything like that. Okay. So I'm going to first, I messed it up like that. Okay. So I have a half sheet of paper. Now I'm going to fold this in half again, just to make it a little bit thinner. Okay. All we're doing really is getting a little strip of paper. Okay. And again, you can cut this, or you can do it like I'm doing and just kind of making a crease and ripping it. It doesn't really matter. Okay, so now what I'm going to do is I'm going to take my one little sheet of paper and I'm going to blow on top of it, right? That's going to create faster moving air on top of the paper compared to the air that's not really moving too much underneath the paper. So what do you think is going to happen? Is the paper going to go up or down? Let's find out. Ready? Did you guys see that? It lifted. So as I'm blowing on top of this piece of paper, that air is moving fast. That fast moving air weighs less than the air beneath it. And that causes the paper to lift up, just like a plane when it's flying, just like most birds when they fly. They use this idea of Bernoulli's Principle. Faster moving air weighs less than slower moving air. And that faster moving air, if it's on top, will create lift under a wing. And the airfoil shape gives you that faster moving air. So let's take a look at that again. Super easy experiment. You can try this at home and see for yourself. Now, let's do another little experiment. What happens if we take our piece of paper and we change its shape a little bit and make it crinkly, right? Let's see what happens when I blow on this piece of paper, this crinkly piece of paper. Nothing, right? The shape of the paper is basically sending the air up. It's not going over the wing, so you don't get lift. And this really, I think, demonstrates very clearly how the shape of a wing can either make lift easier to happen or make lift harder to happen. So let's do a little comparison again. Ready? Ooh, nice lift there. Here, I'll hold this in my other hand so you can see. Oops. Getting some nice lift. And now, no matter how hard I blow, no lift. So again, the shape of the wing is really going to determine whether or not a bird or a plane or just about anything can fly. All right, so with that, I think we're ready to go to the question and answer portion of our segment. So I'm really excited to answer any questions that you guys might have for me.
Thank you for that. And thank you so much for sharing with us that fabulous chapter from your book and that very cool science experiment. I know I certainly learned a lot, especially as you started talking about some of the neuroscience concepts to kick us off today. So we've got our first couple questions here. The first one being, what inspired you to create the characters in the Magnificent Maker series?
Oh, that's a great question. So when I was a little girl, there weren't a lot of characters in books in general that looked like me. And so when I was coming to write this series, not only did I want to make characters that were really excited about science, but I also wanted to make characters that looked like people like me. And I think that representation in science is just so very important. I would have loved when I was younger to have a book with a little girl who loved science just like I loved science and who also looked like me. It would have made me feel really empowered. And so when I got old enough to create my own books, I did just that. I want to empower all kinds of kids to know that you can love science and you can be really good at science, and it doesn't matter where you're from, what you look like, none of that matters. All that matters is that you're curious and you're passionate and you're excited to do experiments.
I love that. And I could not agree more. Representation matters so much in science, and especially all STEM topics. And I love to see the work you've done in that space. What is your favorite installment of the Magnificent Maker series?
Ooh, that's so tough. I really love them all. I'm not going to lie. I would say probably one of my favorite installments would be The Great Germ Hunt. And I think I have it. Yes, I do have it right here in my office. So I think The Great Germ Hunt might be one of my favorites. And that's because the characters in this book do a lot of the same kind of experiments that I do in my lab. They get to use a really fancy microscope, they get to look at bacteria on these little petri dishes. I did that all the time when I was a graduate student. And believe it or not, I wrote this book really early in the pandemic. So I was on, quarantine and very, we were all kind of alone at that time, right? And so I think I grew very close to this book because of the topic and the time in which I wrote it.
We actually had several classrooms that also agreed that was their favorite book from the series too. So you are not alone in picking that one. What aspects of science did you like as a young student, and how did that kind of inspire you to become a neuroscientist?
Yeah, so when I was younger, I've always really been fascinated with the kind of what we call biological sciences or biology, right? And all biology is the study of life. I was so interested about, kind of little questions, right? Why do fireflies' butts glow in the dark? Why do frogs first start out as little fish in a pond? And I don't know if we have anyone who's from the Northern Virginia or the D.C., Maryland, Virginia area, but that's where I'm from. And we have something over there called 17-year cicadas. And I always wondered, what do they do underground for 17 years? And so I've always been very curious about just how the life around me works. But it wasn't until I was in high school And I took a class, an advanced biology class, that I learned about the field of neuroscience. I had never heard of neuroscience before, and I just fell in love. And what really made me fall in love with neuroscientists was this fun fact. Did you know that neurons in our brain and all throughout our body talk to each other, and they talk to each other using electricity? And so when you say like, oh, a light bulb went off, it's not that far from the truth. Neurons send electrical signals all the time, all the time. And even the neurons that are in our skin that I talked about earlier, when I go and touch my skin, that touch is turned into an electrical signal that then shoots to my spinal cord and shoots up to my brain super duper fast, just like a lightning bolt. And so when I learned about that, I said, there's no going back. This is what I want to do. I want to figure out how this works.
That is fascinating and so fantastic. I think that's leads into our next question from fourth grade in Brownsville, Brooklyn. This classroom would like to know, is it possible for someone to not have sensory neurons?
Oh, that is an excellent, excellent question. So I don't think there are any cases where people are absolutely born without sensory neurons. And I actually don't think it would be possible to survive. It is so important that our body, for example, knows what temperature it is, because we're warm-blooded animals, right? So we regulate our body temperature because we know what temperature it is outside. And so if we weren't able to have those sensory neurons that would detect that temperature, we would probably not survive. But interestingly enough, there are some people who don't feel pain. And this is actually kind of dangerous and sad, because when we think about pain, we think about like, oh, I don't want to hurt myself. I don't want to feel pain. No one wants to feel pain, but it's actually very important for learning. When we're younger, and I don't know if you guys have done this, but when I was younger, I would definitely try, and help my mom in the kitchen. And she would always be very nervous about that because she wouldn't want me to burn myself. If I were to burn myself, I never did, but if I were to burn myself, I would learn that I shouldn't touch things that are hot. But kids who can't feel pain don't learn that. And so they tend to injure themselves a lot more. So these sensory neurons are just really, really, really important for us to survive. Very, very important.
That is so interesting, and definitely sad and scary for those that might not have the ability to feel pain. Our next question kind of goes back to your being an author as well as a neuroscientist. And this particular classroom would like to know when you started writing children's books and how long it takes you to write a book.
Great question. So I would say this, I've always been a writer, and I've always been writing stories for kids. But only more recently have I done it as like a profession. So I just want to send this little message before I answer this question, that if you guys are already writing stories, then you're already a writer. Getting them published, that's something different. But you guys, if you start writing stories now, then you can consider yourself writers. So I just wanted to throw that out there. But I would say that I started writing the Magnificent Makers series. Let's see, I think I first got the idea to really go for it right after my oldest daughter was born in the spring of 2017. So I think I started working on these series sometime about 4 years ago in early 2018. And when I first started writing the book, so when I first wrote How to Test a Friendship, which is number 1 in the series, it took me a while. I had never written this book before, and I had to kind of work through it a little bit. Now, when I'm on book 5 and book 6, and actually there's a book 7 coming out too. There's going to be a book 7 that's all about the human body. So when I'm writing those books, it's much faster. And you want to know why? Because I've gotten practice. And so writing is like anything else. The more you do it, the better you become at it. And that's for me too. Even though I'm an author, if I go to start a brand new project, it always takes me a lot longer in the beginning because I'm kind of getting used to this new world and figuring out what the voice should be. So writing writers also have writing muscles. And the more you write, the more you strengthen those writing muscles. So if anyone out there listening is interested in writing stories, start writing now, start writing a lot. I promise you, you're going to get so good at it. I know that.
That's wonderful. And I think you make a great point there that you don't have to have your works published to be a writer or an author. I think everyone definitely has their own writer skill set.
Absolutely.
We've got several folks asking, they'd like to know what your favorite book as a kid was.
Ooh, that's a good one. So when I was younger, I really kind of like scary books. So I don't know if they're still popular, but I loved Goosebumps by R.L. Stine. I would devour those books. I read all of them. So I absolutely loved Goosebumps. I also really liked The Babysitter's Club. That was another series that I really enjoyed. I know that they had like a little Netflix series more recently, and I think they have some graphic novels now of The Babysitter's Club. But when I was younger, they were basically chapter books. So that was definitely one of my favorites. And then for picture books, when I was really young, one of my favorite books that my mom got me was called Just Us Women. I absolutely loved that book, and I loved it for two reasons. One, because it featured a little Black girl like me, and I felt that the girl kind of looked like me. I don't know if she actually did or not, but in my mind, she kind of looked like me. So I felt it was kind of like my story. And then also, even though I grew up in Virginia, I was actually born in a tiny little town in central Pennsylvania called Lewisburg, Pennsylvania. And there's a picture in this book, Just Us Women, with a map. And my little town that like no one had ever heard of was on that map. So I felt very special reading that book. And I think that ties into the motivations I have for writing The Magnificent Makers and featuring brown and Black kids doing science, because I also want brown and Black kids who like science to see themselves doing science and feel kind of seen in the books.
Absolutely. What an inspiration.
Thank you.
Another question about some of your favorite things. What is your favorite thing about science?
You know what my favorite thing about science is? Discovering something that no one else knows. It is so thrilling when you get a new piece of data, you've been doing an experiment. So usually when you start a new experiment, it doesn't work. It takes a while for it to work. That's why science can be so slow sometimes. But once you get it to work and you get that result and you have an answer to a question that no one else has an answer to, I love it. There's nothing better than that. It can be frustrating sometimes, right? So if you want to be a scientist, you have to be able to deal with like experiments fail a lot, but that's okay because scientists never give up. Not most days, at least.
And on that note, what are some ways that you deal with those experiments when they do fail? How do you keep moving and how do you not give up?
So usually, depending on how long they've been failing, I might get a little frustrated, right? Everyone's human. Of course, you're going to get a little frustrated if something fails. But I kind of let those emotions go away. And then I think, okay, I've tried this, and I've tried that. What haven't I tried? What haven't I changed? And then I create a new strategy and test it. And sometimes it works, and sometimes we still have to go back to the drawing board and get really creative. And sometimes we have to take a completely different approach. But basically, I allow myself to feel my feelings. I allow myself to feel a little bit frustrated. And then once I'm no longer so frustrated, I think. And I try and be really careful about how I think about my experiments. And I try and think really deeply. I think sometimes people underestimate the value of just sitting and thinking about something. It's very powerful. And it's actually a huge part of writing. Some people think that writing, I sit down on my computer and just go like this on my keyboard. Half of the time, I'm just sitting there staring and thinking about what the next line should be. So thinking is very important.
That is such good advice. And I think that reminds us all to take a moment when we might be frustrated and just, sit and collect our thoughts and our feelings and then move on.
Exactly.
Let's see. Speaking of thinking, this classroom would like to know how you discover and think about all of the science topics you're putting in your books.
Oh, that's a great question. So I think of the topics from in a couple of different ways. One, I write these books for kids like you guys. And so I'm very inspired by things that you guys are interested in. And so in fact, when I decided to do Race Through Space because when I would do a lot of these these author events early in my career, I would get a lot of questions about black holes. Everyone wanted to know about black holes. And so I thought, you know what? We need a book about space and we need a book about black holes. And believe it or not, in The Magnificent Makers #5, they learn about them. So I get inspiration from children like you all, but I also write these books for your teachers. Your teachers have a lot of work to do. They have a lot of material to cover. They have to cover science, they have to cover reading. And so I try and make books that cover science topics that you guys have to learn about in school. That was where How to Test a Friendship came from. Pretty much everyone has to learn about ecosystems and food chains. So I thought that would be a great book for teachers to have because they could use it for their reading unit, but they could also use it as a tie-in to their science unit. So I'm trying to make the job easier for teachers. And then lastly, I also write a little bit for myself. So for example, the Brain Trouble book, unfortunately, the brain is not on the standard curriculum. Most, second, third, fourth graders I didn't even learn about the brain until I was in high school, really. And so I thought that should change. And so Brain Trouble, for example, was just my idea about what I thought that kids should learn about as well. So I try and balance a little bit of everyone's needs when I'm thinking about the different science topics.
That's awesome that you approach writing with such an inclusive mindset. I think that's so fantastic. And I'm sure our teachers and students alike here today also appreciate that.
Thank you.
Speaking of balance, we have another classroom that would like to know how you balance being a neuroscientist, an author, and a mom and a family member.
Yeah, it's not easy. And some days I do a better job of balancing than others. But in the end, all three of those things are very, very important to me. And I don't want to have to I'm obviously not going to give up my family, right? But I don't want to give up my job. I love working in the lab. I love it as much as I love writing. And you know what? I think they all kind of satisfy different parts of my personality. And so maybe if I'm really frustrated in the lab, I was like, you know what? I'm just going to think about some new Magnificent Maker ideas today because I don't want to deal with that experimental failure right now. Or maybe I'm sitting here and I'm stuck and I'm writing and I don't know what else to say and I don't have any good ideas. I can hop over to the lab and get inspired by the actual science that's going on around me. And then for me, my daughters are 3 and 5. And so they're finally getting a little bit old enough for me to be able to read my books to them. And so I try and also incorporate them into my work. They know that mommy's a scientist. They know that mommy writes books. And so I just try and create a lot of nice overlap between all of those different things that I do. And I think that they help balance me.
That's wonderful. And I think it definitely is exciting when you have a few different things you can work on and pop between to help make sure that you are balancing your life for the things that you need in each moment. And we've got time for just one more question. And this question comes to us from Florida. And they would like to know, who was your biggest supporter growing up and as well as now as you are in these different careers that you have?
I would have to hands down say my parents. I feel very lucky that they very much valued books and reading and writing and education. They both grew up kind of poor. My dad was from a little island in the Caribbean called Barbados. And when he was growing up, he didn't have running water or electricity. And then my mother grew up in Akron, Ohio, and she was the oldest of 7 children, and her parents were factory workers. And so both of them had to work really hard to achieve what they achieved, which was a lot. They are also college professors. And they also wanted to help me achieve the things that were harder for them to achieve. So they've always been my biggest fans and really, really supportive of me. And I feel I owe them so much. Unfortunately, my mother passed away about 8 years ago, but I still have my dad, and he still buys all my books, and he still sends me messages about how proud he is of me. So I would absolutely say my parents, now my dad, and then also my husband. Kind of going back to that question about balance, I would not be able to do what I'm doing if I didn't have a very, very supportive partner. So definitely my dad and my husband kind of keep me going and keep cheering me on.
That's wonderful. I love the inspiration and support system you had growing up as well as now. And so sorry that your mom is not with us any longer, but I'm very excited that your dad is still one of your number one supporters and sending you all of the love and notes on all of the work that you've got going on. But with that, want to just say thank you so much, Dr. Griffith, for joining us today. It's been such a wonderful session to wrap out our STEM Careers All Year series this year and this school year. Could not thank you enough for your time today. It's been so fantastic. And with that, I will pass things back over to Allison.
Thank you, GM, Kelsey, and our wonderful guest, Dr. Griffith. What a fun hour this has been. I also want to extend a very special thank you to all of the educators, teachers, and students who have participated in our STEM Careers All Year events this past school year. Please be on the lookout for a survey in your inboxes next week. We really appreciate your feedback on how these events have gone, and we hope to continue to deliver similar events to our First Book network. And finally, please check out the GM-sponsored Diversity in STEM page on the First Book Marketplace. Happy reading and happy weekend. Thank you.